All right, welcome. Today we are digging deep, and I mean that literally, into the incredible multi-billion-year story of how the very ground under South Africa was put together. We're talking a story of fire, immense pressure, and just an unbelievable amount of time. So let's get into it.
I mean, how do you even wrap your head around that question? It's just a mind-bending scale. We're not talking about a few hundred years or even a few thousand. We're talking about geological deep time, a stretch of history so vast it shaped not just a country, but our entire planet.
Okay, so here's our game plan for this journey. We're going to start with the absolute basics, the building blocks of our world. Then we'll check out the massive engine that moves them around. After that, we'll see how those forces actually assembled Southern Africa, what treasures that process left behind, and finally, why any of this ancient history is still so important today. First things first, Earth's fundamental blueprint. You know, you can't build a house without knowing what bricks are made of, right? Same idea here. Before we build a continent, we need to know what it's made from. And it really all boils down to three main types of rock. So first up, we've got igneous rocks. You can pretty much think of these as the planet's OG building blocks, born directly from fire. They're what you get when super hot liquid magma from deep inside the Earth cools down and hardens into solid crystalline rock. Think of granite. That's a classic igneous rock. Next, you've got sedimentary rocks. Now, I like to think of these as the great recyclers of the planet. They're basically made of leftovers, little bits and pieces, sand, silt, pebbles, you name it, from older rocks that got worn down by wind and rain, washed away, and then eventually pressed back together over millions and millions of years. And rounding out our trio are the metamorphic rocks. These guys are the transformers. They start their life as either igneous or sedimentary, but then they get shoved deep underground and subjected to just insane amounts of heat and pressure. They don't quite melt, but they completely change. Their whole chemistry and structure gets rearranged into something totally new, like when limestone becomes marble. So this table here really lays it all out for us. You can see those three paths clearly. Brand new rock from cooled magma, recycled rock from old debris, and transformed rock from heat and pressure. That's it. That's the whole toolkit. With these three types of rock, you've got everything you need to build a world. Okay, so we've got our building materials, but here's the thing. They don't just sit still. There is a colossal engine deep inside the Earth that is constantly churning and moving these pieces around. Let's take a look at this restless engine. And to get what drives everything, you've got to look inside the Earth itself. It's not a solid ball of rock, it's built in layers. You've got this blazing hot solid iron ball at the center, a liquid metal outer core around that, then this huge, gooey, slowly moving mantle, and on the very top, this paper-thin, fragile crust that we call home. And that whole setup, all those layers with that incredible heat trying to escape from the core, well, that creates a ridiculously powerful engine, one that's been running nonstop for over 4 billion years. And this is exactly how it works. You see those big swirling arrows in the mantle? That's the planet's core heating up the rock below, causing it to rise, cool, and sink again. It's kind of like a gigantic super slow-motion lava lamp. The crust on top is shattered into these massive plates that just float on this churning mantle, getting dragged around like rafts on a current. That, in a nutshell, is plate tectonics. All right, we've got the materials, we've got the engine. Now let's put it all together and see how these incredible forces actually built the subcontinent of Southern Africa, piece by painful piece. And again, you really have to adjust your sense of time here. The story kicks off about 3.5 billion years ago with the very first bits of stable land forming. Way later, around 600 million years ago, all these bits smashed together into the supercontinent Gondwana, only for that to start ripping itself apart about 180 million years ago. So continents don't just pop up out of nowhere. They're built around these super old, super stable foundations called cratons. You can see them here on the map of Africa. And for the story of South Africa, the two most important ones are the Kapval and Zimbabwe cratons. You can think of them as the original, ancient pillars that the rest of the subcontinent was built around. And for a huge chunk of time, hundreds of millions of years, those cratons were all huddled together as part of one gigantic supercontinent called Gondwana. This map shows what scientists think it looked like. And you can literally see how South America tucks into Africa and how Antarctica, Australia, and India all slot in perfectly. It was a completely different world. But you know that restless engine we talked about? The one that brings things together? Well, it also tears them apart. And this colossal landmass was not going to last. The forces that built it were about to begin one of the most violent breakups in the history of our planet. That violent breakup, and all the geological drama that came before it, left something behind. A legacy, really. An inheritance buried in the rock that has shaped everything that came after. So let's zoom in on one spectacular example. You have the ancient Cup Craton, that stable foundation we mentioned. Then, about 2 billion years ago, a truly enormous bubble of molten magma, we're talking huge, forced its way up from the depths and injected itself right into that ancient craton, where it slowly cooled and solidified into the Bushveld igneous complex. And when I say unique, I mean there is literally nothing else like it on Earth. That one event created the world's single richest deposit of platinum. It also locked away mind-boggling amounts of chromium and vanadium. It's so special, it's become this one-of-a-kind natural laboratory for geologists from all over the world. So who cares, right? A bunch of weird rocks formed 2 billion years ago. Why does any of that matter today? Well, that's where we connect the dots, from deep time straight to the 21st century global economy. It matters because of this number. Just look at that. 68%. What is that? That's the percentage of all the world's known chromium reserves. 68%. And it's almost entirely thanks to that one geological feature we just talked about, the Bushveld complex. And believe me, it is not just chromium. This ancient geological lottery has made South Africa an absolute titan of mineral wealth. For decades, it was the world's #1 gold producer. Today, it holds over half the world's platinum group metals, over 80% of its manganese, plus incredible amounts of diamonds, coal, and iron ore. You know, this quote here really just nails it. The physical geography of South Africa, as well as its economic base, depends to a large extent on the regional geology. The ground beneath your feet isn't just ancient history, it's the blueprint for the world we live in right now. So what this all comes down to is that the ground we stand on, it isn't just rock and dirt. It's a library with a history billions of years old written into its layers, a story that is still being written today. It really makes you think, doesn't it? What secrets, what stories of fire and ice and incredible pressure are locked in the ground right under your feet?